Okay, let's be real. Artificial intelligence is, well, it's everywhere. But it's also surrounded by this, confusing cloud of buzzwords, right? So in this explainer, we're going to cut right through all that noise. We're going to build a clear blueprint and show you what it all really means.
I mean, you hear these terms thrown around constantly. AI, machine learning, generative AI. So are they just different words for the same thing? Or are they actually distinct pieces of a much bigger and, honestly, a way more exciting puzzle? Well, let's find out. First up, let's talk about the AI explosion. It really feels like just yesterday that AI was something you only saw in sci-fi movies. And now? Now it's recommending your next TV show. It's writing your emails. It's even creating this unbelievable art. It's wild.
And you've definitely seen it in action. Maybe you've played around with a chatbot that can whip up a whole essay in seconds, or an AI that turns a few words into a stunning piece of art. And of course, there are those mind-bending deepfake videos, and even the autocomplete on your phone that basically reads your mind now.
So here's the secret to understanding all this. These things aren't just random separate technologies. Nope, they're all part of the same family tree. Think of it like a set of those Russian nesting dolls. So let's start opening them up and see what's inside.
So now it's time to actually build out this AI family tree. I promise this is where it all starts to click. We're going to start with the biggest, oldest idea and work our way right down to the super cutting-edge tech that's making all the headlines today. At the very, very top of the family tree, the great-grandparent of it all, is artificial intelligence, AI. This is the big umbrella idea that started everything decades ago. It's the huge ambition to build machines that can think, that can reason, and that can learn. Just like humans do. Okay, so tucked right inside AI is its most important offspring, machine learning, or ML. And this approach is absolutely brilliant. Instead of trying to write a million lines of code with rules for every single situation, you just feed the computer a ton of data and let it figure out the patterns on its own. Ever wonder how your music app just knows what song you want to hear next? Yep, that's machine learning at work.
Now we're getting to the really powerful stuff, deep learning. This is like a special supercharged version of machine learning. It uses these things called neural networks, and you can kind of think of them as a simplified digital version of a human brain. The deep part, that just means there are lots and lots of these layers stacked up, which lets the AI handle incredibly complicated stuff, like understanding what you're saying or recognizing faces in photos.
And that brings us to the very heart of the nesting doll, the thing that has caused this recent explosion, generative AI. This is where it gets so exciting. It takes all those other layers we just talked about, AI, machine learning, deep learning, and uses them not just to understand the world, but to create brand new, original things. I absolutely love this analogy. Think about music. There are only so many notes, right? But somehow, people are creating brand new songs every single day. Generative AI is kind of like that. It learns from all the existing information it's been shown, and then it finds these new creative ways to recombine it all to make something that feels totally original. Okay, so we've got the what. We understand the family tree. But that just brings up an even bigger, kind of mind-bending question. How in the world does a machine actually learn? I mean, it's not like it's going to school.
The whole process is actually pretty incredible when you get down to it.
And it turns out it really just boils down to 3 basic styles of learning. And once you get a handle on these 3, you'll have a much, much better idea of what's actually happening inside that AI black box.
So let's break them down, the 3 main styles of machine learning: unsupervised, supervised, and reinforcement.
So here's the quick overview. Unsupervised learning is kind of like telling an explorer, go into this new territory and just find interesting stuff. Supervised learning is more like a student with a teacher who gives them a bunch of examples and corrects their homework. And reinforcement learning, that's like training a pet. It learns by getting rewarded for doing the right thing.
First up, we have unsupervised learning, the explorer. This is what you use when you've got this massive pile of data, but you're not even really sure what you're looking for. You just unleash the AI on it and tell it to find hidden connections. Imagine a company sifting through thousands of customer profiles and suddenly discovering a whole new group of people with similar interests that no one even knew existed. That's the power of this approach.
Next is supervised learning, the student. Now, this is what you use when you have a very specific goal in mind. The key here is you give the AI a bunch of examples that have already been neatly labeled by humans. For instance, you could show it thousands of medical images, some with a disease, some without, all labeled by doctors. After seeing enough examples, it eventually learns to spot the disease all by itself.
And last but not least, we have reinforcement learning, the strategist. This one is all about learning through trial and error, and it's perfect for really complex problems where there's no single right answer. The AI tries an action. If it leads to a good outcome, it gets a reward. If it doesn't, it gets a penalty. This is exactly how AIs have mastered incredibly difficult games like chess and Go, and it's also being used for amazing things like figuring out the most efficient way to manage traffic in a city.
So, we've seen the structure, we've seen how it learns, and it's pretty clear we are building something unbelievably powerful. But you know what they say, with great power comes some really big challenges.
And one of the biggest challenges is something called the black box problem. See, as these AI systems get more and more complex, it actually becomes harder for us humans to understand why they make the decisions they do. We can see the data that goes in, and we can see the answer that comes out, but what happens in the middle can be a total mystery. And that can be a little unsettling.
It's fascinating to go back and think that for Alan Turing, one of the pioneers of all this, the ultimate test of a machine's intelligence wasn't solving some crazy complex math problem. It was just being able to make small talk, to have a normal conversation. And honestly, when you talk to some of the chatbots we have today, it really feels like we're getting closer than ever to passing that test.
And that really brings us to the final and maybe the most important question of all. We've already built machines that can learn on their own. Now, we're building machines that can teach themselves. As this technology races forward, the biggest challenge we face might not be technical at all. It might be a moral one. How do we make sure that the intelligence we're creating actually shares our values? That right there, that is the question that's going to define our future.